Researchers have discovered that Saturn's moon, Enceladus, could support life in its subsurface ocean. Using data from NASA's Cassini spacecraft, scientists and researchers at the Southwest Research Institute have created a model of chemical processes in the subsurface ocean of Saturn's moon Enceladus. The research indicates that there is a possibility that a varied metabolic combination could support potentially diverse microbial community in the liquid water ocean beneath the moon's icy facade. Prior to the deorbit of Cassini in September 2017, it sampled the plume of ice grains and water vapor which erupted from cracks on the icy surface of Enceladus, thus leading to the discovery of molecular hydrogen, a potential food source for microbes. It should also be noted that many believe that it is a good idea to explore the oceans of Enceladus for potential energy sources. The detection of molecular hydrogen in the plume indicates that there is free energy available in the oceans of Enceladus. They further stated that on Earth, aerobic or oxygen-breathing creatures consume energy in organic matter such as glucose and oxygen to create carbon dioxide and water. Anaerobic microbial life can metabolize hydrogen to create methane. All life can be distilled to similar chemical reactions associated with the disequilibrium between oxidant and reductant compounds. This disequilibrium creates a potential energy gradient, where redox chemistry transfers electrons between chemical species, while another species undergo reduction, while most with one species go in oxidation phase. These processes are vital to many basic functions of life, including that of photosynthesis and respiration. Take, for example, hydrogen is a source of chemical energy, which supports anaerobic microbial life that live in the Earth's oceans near hydrothermal vents. At Earth's ocean floor, hydrothermal vents emit hot, energy-rich, mineral-laden fluids that allow unique ecosystems that are teeming with unusual creatures to thrive. Previous to this research, studies had found growing evidence of hydrothermal vents and chemical disequilibrium on Enceladus, which hints at habitable conditions in its subsurface ocean. The scientists and researchers would have wondered if other types of metabolic pathways could also provide sources of energy in Enceladus's oceans, because that could require a different set of oxidants that we have not yet detected in the plume of Enceladus. They performed chemical modeling to determine if the conditions in the ocean and the rocky core could support these chemical processes. They further went on to state that if ionizing radiation from space could create the oxidants O2 and H2O2, and how abiotic geochemistry in the ocean and rocky core could contribute to chemical disequilibria and might support metabolic processes. The team of researchers have considered whether these oxidants could accumulate over time if reductants are not present in appreciable amounts. They also considered how aqueous reductants or seafloor minerals may convert these oxidants into sulfates and iron oxides. They compared the free energy estimates to ecosystems on Earth and determined that overall, their values for both aerobic and anaerobic metabolisms meet or exceed minimum requirements. These results indicate that oxidant production and oxidation chemistry could contribute to supporting possible life and a metabolically diverse microbial community on the moon of Enceladus. Now that they have identified these potential food sources for microbial life, their next question is, what is the nature of the complex organics that are coming out of the ocean? Of course, many persons are wondering, is life existing on Saturn's moon, Enceladus? This will help them to go to a closer understanding about how a small moon can sustain life in ways that completely exceed their expectations and that of others. This serves as great significance for the next generation of explorers of space and planetary life. A spacecraft would fly through the plume of Enceladus to test the predictions that have been made by the researchers. They will also need some testing on the predictions that have been made on the abundances of oxidized compounds in the ocean of Enceladus. This is quite fascinating. Like, comment, share, and subscribe, and let me know what you think about the possibility of microbial life existing in the oceans of Enceladus, one of Saturn's moons. Are you excited about this information? Well, we have to wait and see if these predictions will be confirmed by the spacecraft which will travel through the plume of Enceladus in the future. Thanks for watching. Goodbye.